Oke, Assalamualaikum warahmatullahi wabarakatuh.
Good afternoon.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, maybe
Waalaikumsalam.
we can start this webinar. Good afternoon, distinguished guys, respected speaker, and all participants joining via Zoom and YouTube. My name is Dr. Insinyur Alfa Adib, Vice Secretary for Transport, Institute of Civil Engineers. I will serve as your Master of Ceremony and moderator for today's session. Welcome to the International Webinar of Road Safety. Road safety on toll road design with the case study Jambi Rengat toll road. This webinar is jointly organized by BK Sipil PII in collaboration with AIIB and the Directorate General of Highways. Thank you for joining us today on this Friday afternoon. Okay, first I will inform the agenda today. It will be opening remarks from Vice Chairman of Transportation BK Sipil PII, opening remarks from AIIB, and then main presentation by speaker 1 and then speaker 2, continued by Q&A, question and answer, and then closing remarks by Chairman of BK Sipil PII. And now, ladies and gentlemen, before we begin, let us start with our ceremonial opening. First, we will sing the national anthem Indonesia Raya, followed by the hymn of PII. Okay, operator, please play Indonesia Raya.
Mempersatukan Nusantara, membuka cakrawala dunia. Kami insinyur Indonesia, kami memajukan bangsa, mensejahterakan masyarakat untuk kemajuan.
Thank you. And now we will proceed to the main program. But before to formally open this webinar, we will start with opening remarks from Pak Dedi, Insinyur Dedi Gunawan, STMSC, Vice Chairman for Transportation, Institute of Civil Engineering, at PK Sipil PI. Pak Dedi, the floor is yours.
Okay, thank you, Mr. Afif. Bismillahirrahmanirrahim. Welcome to this Diraja Supla, Senior Investment Officer for Transport. I think this is from the IEB, with Brigadier N. Bashar, Senior Deputy Engineer of IRAP, with Anhu, Senior Engineer, Deputy Director from Beijing, kemudian Huang Technology Technology. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good afternoon, ladies and gentlemen, distinguished guests, colleagues, and fellow experts. First of all, on behalf of the Civil Engineering Department, the Indonesia Institute of Civil Engineers, allow me to warm welcome all participants to the International Road Safety Webinar with the entitled Road Safety on the Road Design Case Study Jambi Rengat Road. This Jambi Rengat Road is part of the Trans-Sumatera Road, which is now still under the preparation for construction, and maybe it will be funded by the IEB loan. It is honor for us to co-organize this event together with our fellow partner, the Asia Infrastructure Development Bank, and also the Directorate of Freeway, Directorate General of Highway. Bapak, Ibu, and all guests and colleagues, we are meeting today with a shared mission to strengthen the safety performance of our toll road and expressway, not only as infrastructure asset, but as a living corridor that carry human life every day. Toll roads operate at high speeds, carry large traffic volume, and therefore concentrate high severity traffic. So when design, operation, and enforcement are not fully aligned, even small gaps such as unclear interchange marking, insufficient roadside protection, or weakness in the median remote can have devastating consequences. This is why road safety on the road must be treated as a core performance requirement, not an additional feature. From the perspective of civil engineer, this is not only technical responsibility, but it is also moral responsibility. I think it's important than the technical and the moral. This webinar is designed as practical knowledge sharing and capacity building platform, aligned with the direction to maintain the system approach, ranging from planning, design, construction, operation, and maintenance. So the discussion in core on a strong real-world case, the technical work on road safety review enhancement for the Trans-Sumatera Road, focusing on the Jambi Rengat Road. In fact, the detail engineering design is already conducted by local consultant, but then the reviewer by the AEB road safety team. During the review, IRAP start writing for design or SR4D and road safety audit of design drawing is done in order to identify risk factor and propose targeting countermeasure for safer outcome. Ladies and gentlemen, we will explore criteria for the review, including issues such as median opening, particularly emergency pollution provision and barrier and protection, interchange match and differ match delineation, and other supporting measures such as variable missing time placement, fencing continuity, protection for vulnerable road user where relevant, anti-glare screen, and speed enforcement readiness. Distinguished ladies and gentlemen, Let me also highlight the expected outcome of today's webinar. First, we aim to build shared understanding of priority risks and practical countermeasures for the Torah project based on SR4D and design audit findings. Second, we want to strengthen technical capability among engineers and practitioners to apply SR4D and supporting digital tools such as SPIDA for evidence-based decision. Third, we want to align on how recommendation can be translated into actionable steps, covering design refinement, interchange enrichment, roadside safety, and speed management, and also investment readiness. And then finally, we hope to define a follow-up pathway to mainstream road safety provision within expressway delivery and operation. So the learning does not stop here, but continues through implementation and simulation. Ladies and gentlemen, allow me to acknowledge and thank to our speaker and the team supporting this effort. Especially, we are privileged to have Mr. Tingal and Bas Far as a senior road safety engineer, IRAP, and also Ms. Han Hu, senior engineer or deputy director from Beijing Zhongjiahun Technology, and also the Research Institute of Highway. So they will present on the road safety aspect of Jambi Rengat road design case study. To the all participants, I encourage you to make a full use of discussion and question and answer. Tell your suggestion, your local case, and even your pain point. Our goal is to act simulation we can apply on our work, not only in theory. Thank you and have a good discussion. Wassalamualaikum warahmatullahi wabarakatuh. Good afternoon. Back to you, Mr. Adit.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Pak Dedi, for the clear and inspiring opening remarks. Next, we are honored to receive opening remarks from our partner from EIIB, Ms. Niraja Sukla. She is a senior investment officer for transport AIB with more than 16 years of experience in the transport and logistic field. Okay, Ms. Niraja, please, the time is yours.
Thank you, Pak Alpha. I am firstly very, very honored and excited to be part of this gathering. Thank you very much, Pak Teddy, for a very inspiring opening remark. We are very much honored to have partnered with Ministry of Public Works in this very exciting project of Trans-Sumatra Highway. We are not just the financial partners to the project, we are also technically, a very well-equipped team, and we are partnering on various aspects of the project, including the technical, and one of the technical elements is road safety. So I'm very, very, contented with our consultants here who are on board today, Beijing Zhongjiang consultants today, and they are going to elaborate on two aspects. One is the overall road safety, developments that are happening in various parts of the world. What are the recent trends, what are the developments, etc. And the second part would focus particularly on Jambi Rengat Toll Road. We request you and we urge you to please engage and please provide your feedback, your opinion on the various technical aspects of this project. Once again, very, very honored and grateful for this opportunity to the entire Ministry of Public Works team. And I would not take much of your time, but I will pass it back on to Pak Alpha, and very happy to be here. Thank you.
Thank you very much, Ms. Niraja, for your thoughtful remarks and continued support for road safety. We now enter to the main technical session. Our first speaker is Ms. Han Hu, a senior engineer and deputy director at Beijing Zhongjiahun Technology Co. Limited. Her work focuses on applying evidence-based approach to safer road infrastructure, turning design and operational risk into practical recommendation. that can be implemented on real project. This aligns strongly with today's session, where she will share the Jambi Rengat toll road design case study, including key funding and improvement options. With great respect, Ms. Hanhu, are you ready? Ms. Hanhu, the floor is yours.
I think Niraja, maybe Jigesh is the first module one, or you want me to talk
I
first?
think Ajib, if it's okay, we can first take up the element of the overall, road safety aspects, and then we'll focus on the case study, if that's okay.
Okay,
can-
okay.
Pak Jagesh go first.
Okay, so okay, the first speaker will be Pak Jiges, Mr. Jiges Basfar. Mr. Jiges Basfar is a senior road safety engineer from the International Road Assessment Program, IRAP. He also serves as India RAP's technical manager, supporting partners to apply the IRAP methodology and translate evidence into life-saving designs and investment decision. Mr. Jiges, are you ready? The time is yours.
Yes, thank you. Thank you very much. And thank you for giving me this opportunity to speak. I'm going to share my screen. I hope you'll be able to see my screen. That's okay. So I'm going to speak about general information on road safety and good practices around the world, mainly focusing on the road infrastructure safety, but also will touch upon other aspects of road safety, especially safe system approach. To start with, let me share with you the global safety challenge that we are facing. Road safety challenge. Every year, 1.18 million people die on roads because of the crashes or accidents, as we know. That is about 15 deaths per 100,000 population. So 15 is the global average number per 100,000 people. 15 people die because of road crashes. That amounts to 51 million annual deaths and serious injuries. That's a huge number. Also, these huge number results into about $3.6 trillion of losses because the people who die or get serious injury, that often ends up in hospital. It becomes a burden on the health system, as well as the annual losses to the country in terms of GDP, etc. So this again amounts to 3.7% loss of annual GDP on an average to all countries. So that's a huge loss to each nation in terms of GDP loss. However, the more worrisome figure is road safety crashes is the leading cause of death for young people aged from 5 to 29. So you can think of children, school-going children, or adults, young adults who just start earning in their early life. They are the victim of road crashes. And you can imagine the effect on the families. Often in low and middle income countries, this effect is bit more worrisome because there is single person who is breadwinner or earning, and the whole family is devastated. So that's the overall impact of road crashes annually every year. So this chart here, it shows the numbers, and these are coming from the Safety Insight Explorer available on IRAP website. So you can see every year 1.18 million people die, and that amounts to about 3,000 people getting killed every day. So that's a huge number. The big number, you can see number of fatalities. There is some background noise. Thanks. So in addition to the number of deaths, the number of injuries is the number is huge. You can see here different type of injuries annually fractures or different type of major injuries, and some of them are permanent injuries. So you can see this total number of fatalities and injuries is 51 million, and that's a huge number. On an average, in the all countries, for every $100, that that is the cost to the community. So, and every $100 loss, we spend just $1 to $3 to prevent crashes, which is very small amount compared to the losses. So that's the global number. Looking at the Indonesia, in Indonesia, every year 31,000 people die because of road crashes, and this is as per WHO estimate from year 2021. There is little difference between the country reported deaths, which is 25,000, so which is reported by the government system. However, WHO estimates a little bit higher, 31,000 deaths. If we look at the number of fatalities per 100,000 population, Indonesia comes at 11 deaths per 100,000 population. The global average is 15, so Indonesia is slightly below the global average. Again, in Indonesia, the road safety challenge, if we look at this chart here, the young people in the age of 15 to 44 years of age group, they are the biggest share in total number of fatalities. Looking at the vehicle types involved, motorcycles or the motorized two-wheelers are the biggest group. 80% of the deaths are with the motorized two-wheelers. And this is not surprising. In fact, the majority of the number of vehicles are also motorcycles in Indonesia, and not only Indonesia, other countries in Asia also, they have similar trend. WHO and United Nations, they have put together a global plan as part of Decade of Action for Road Safety. So the current decade, 2021 to 2030, is the second decade of action for road safety. And WHO has prepared a global plan detailing what is to be done to address the issue of road safety, how to do it, the steps required to achieve the target of 50% reduction, and what to do, who to do it. So which are the agencies who need to take the actions. So this is a very detailed action plan. Also, if we look at the road safety or the infrastructure assessment in Indonesia, more than 31,000 kilometers are assessed by IRAP at the current stage. And if we look at the percentage road length achieving 3-star or better, pedestrians, just 7% of the road length is safer for them. For bicyclists, 14%, motorcyclists, 32%, and vehicle occupant, 55% of the road length is 3-star or better. So the remaining chunk of road length which we look here is either 1-star or 2-star. And for pedestrians and bicyclists, which are more vulnerable, the unsafe road length is even more. Again, as a part of the Global Road Safety Action Plan, the Global Road Safety Action Plan, there are 12 global performance targets. Can you please confirm if you are able to hear me?
Yes, it's okay.
Okay, thanks. So I was mentioning about the 12 global performance targets given by the Global Road Safety Action Plan. So the overall target is to reduce the number of fatalities and serious injuries by 50%. And as I mentioned, there are multiple agencies involved. So all these 12 targets are meant for different agencies. Some of them are for the law enforcing authorities. Some of these are for the road authorities who construct and maintain roads. Some of these are for the health emergency providers and so on. So target number 3 and 4, these two target they talk about road infrastructure and which is more relevant to the authorities constructing and maintaining roads. So target number 3 is for existing is for the new roads, which means when we are upgrading a road, it becomes a new road. So this target says that all such roads, they should achieve better road safety or 3-star rating target. So the new roads should be designed in such a way that they achieve at least 3-star rating. And they should undergo a very good road safety audit and road safety assessment process. Target number 4 is for existing roads where the roads are already developed and you can say roads are under operation and maintenance status. On such roads, 75% of travel should happen on 3-star or better road for all road users. So that's the 2 targets given under the Global Road Safety Action Plan pertaining to the road authorities, road construction and maintenance authorities. Again, coming back to the Indonesia, if we think of a scenario where we want to achieve target number 4, where all existing roads under operation conditions, they should achieve 3-star or better rating, ensuring 75% of travel. What this chart shows here, the annual loss to Indonesia is about $38 billion because of road crashes. Spending $1.7 billion annually, which is just 0.1% of Indonesia's GDP, that will help us to prevent 10,000 deaths every year. So that's huge achievement, spending 0.1% of GDP every year in a systematic manner to improve safe or to have safer road infrastructure that gets very good benefit. The benefit cost ratio overall is 10, which means every dollar spent on targeted safety improvement, that will get $10 of benefit. So this is a very good promising plan, which is a very high level plan, of course. Then we will have to do more detailed assessment. And as I said, 31,000 kilometers have already been assessed in Indonesia where a good plan exists. Also for the TSTR link under this study, we have done assessment as Han will be talking in next module. Now there are some good global policy leadership from multiple countries I'm showing here on this slide. So what they have done, they have done assessment of the major road network or strategic road network of the country, and that tells that how much road length is high risk, say 1 and 2-star, and then prepare a plan if we want to improve them to 3-star rating level. What infrastructure improvement is required, how much cost is required to invest to improve that to 3-star rating, and how much time is required. Based on that, they prepare a plan for next 5 years and 10 years. And some of the countries like UK, Australia, they have achieved those targets. But also a very good news that Indonesia also have adopted such policy target, which says that more than 75% of travel should be on 3-star or better on the new roads. So that's a good policy level adoption by the Indonesian government. Now our job is to make sure that these are implemented on every new road project, and TSTR is one of them, which is a good thing. So this is about the how road safety policies and action plan help us to make roads safer and save lives. Now I will also like to talk a bit about safe system approach. So the traditional approach on road safety versus safe system approach. Many developed countries, they adopted the safe system approach many years ago, like Australia, UK, countries in Europe. They adopted the safe system approach in 1980s and 1990s. And after that, we see a great reduction in number of crashes in those countries. So what safe system approach says basically is um, people are vulnerable and people make mistake. So we should not blame the driver for a mistake that he or she commits on the road and the crash happens. We should think that people are not people are human, not machine. They will sometime make mistake. Even if we have good training of drivers, all sober drivers, not drinking, wearing seatbelt, etc. But still, people sometimes make mistake, or there may be some other reason like bad weather or something, and crash happens. In such a case, how can we make sure that the outcome of the crash doesn't result into death or serious injury? So prevention of deaths and serious injuries on the roads, that is the focus of safe system approach. Now, there are multiple road agencies who need to work together, or who often make a team and work together under the safe system approach. So you can see safer vehicles with good vehicle technology, safer speed. So we should first understand what is the safe speed for a particular road environment, and how can we implement those safer road infrastructure. So this is police, this is road authority, post-crash care, where when a crash happens, the victim must be taken to the hospital in a short time. So good ambulance system and trauma centers, so the healthcare system, and safer road users, where drivers are trained in a proper way through a good licensing system. All the people on the road who are vulnerable, bicycles, people on wheelchair, etc., they are taken care by proper road infrastructure, plus the facilities. So all these component, they work together as a team to avoid or reduce number of deaths and serious injuries. And we need to strengthen all these aspects to achieve road safety. So again, as part of the safe system approach, we tend to focus more on proactive approach. So I'm sure you know about the two basic approaches on road safety, particularly when we talk about road infrastructure or the engineering part of the road: reactive and proactive. Reactive is more based on crash data, or you might have heard about black spot programs. So on a road, when more crashes are happening on a particular site, that is termed as a black spot, and uh, treatments are implemented or countermeasures are adopted to reduce the number of crashes or avoid number of crashes on such. However, that is reactive approach. And the more proactive approach is road safety audit, road safety inspection, road safety assessment, where we want to make sure that a new road or existing road, the chances of number of crashes are reduced by having some systematic safety improvements. Now, as you can think of speed is the very important aspect when it comes to crashes and injuries. So this chart here on the left, it shows collision speed at which a vehicle hits a pedestrian or another vehicle. And here on this axis, fatality risk, that is the percentage chances of death. So for example, pedestrian, when hit by a vehicle at 30 km/h, the chances of death is 10%. So 90% chances of survival. At 40 km/h, about 40% chances of death. But then when you see at 50 km/h, the chances of death are very high, 80%. So very less chance of survival for pedestrian. So that's why when we have mixed kind of use and no segregation of pedestrian, 30 km/h or maximum 40 km/h is a good approach. If we want to have higher speed, then we'll have to have good facility, segregation of the pedestrian and vulnerable road users. Vehicle-to-vehicle collision, side collision, which happens at intersections, 60 km/h, about 40% chance of death, 70 per kilometer, it is very high. So that's why when you look at intersection, these are very critical part of infrastructure. And then head-on collision, 70 km/h is the limit. Beyond 70 is going to be very high. The chances of death is going to be very high. Now this table here, it shows a very good it is a very good indicator of speed and safety relation for different road user type. So for pedestrian, if we think of a situation where there is no sidewalk or that is no footpath or no safe crossing, and the speed is 60 km/h, it gets just 1 star for pedestrian. Speed is slightly less, 50 km/h, and when we have good footpaths, refuge, or good crossing facilities and street light, it gets 3-star rating, which is good. And even lower speed, 40, and slightly more better infrastructure like signalized pedestrian crossing, it gets 5-star rating. If we look at vehicle occupant, a situation where undivided road like 2-lane road, 100 km/h speed, 1-star rating, which is very high risk. Whereas if we look at a road, a good road, maybe like a motorway, just like a TSTR road, 100 km/h speed, having safety barriers between two direction of traffic, and also on the sides, it gets 5-star rating, which is a good safer infrastructure. So based on the type of road infrastructure, we can say what speed is safe. So if we are going to have more speed, we'll have to upgrade infrastructure or limit the speed to that level. So this is a good indicator which helps us to understand what is the safer speed for given situation. Also, having a good infrastructure data, good level of infrastructure data, that is very helpful. This is particularly from IRAP assessment in some country in Europe. Sorry. So what it shows that plotting multiple layers of data, like where speed limit is more than 50 km/h, we have pedestrian crossing like the one shown in the photograph, at grade pedestrian crossing, just a zebra marking, multiple lanes. So you can see 4 lanes of the road. So pedestrian will have to cross very wide lane. 4 lanes is very wide for pedestrian to cross, and undivided. So there is no refuge in between. So when you enter the road, you have to cross, and you can see here, pedestrian probably cannot see if there is another vehicle approaching from this side. So that type of combination of high risk parameters that helps us to identify such high risk locations on the site. There are multiple other parameters as well, like curvature without signs and marking. Nighttime, you can see it's going to be very high risk, particularly on high risk roads and so on. So having such a detailed data, it also helps to identify such high risk situations. Now there are several international good practice available when we talk about safer road infrastructure. There are some like Austroads in Australia, DMRB, which is from the UK, and PARC, CAREC for the Central Asia region, and so on. So what they talk about is not just the geometric design. Obviously, geometric design of the roads is very important, but also speed management in the urban or rural areas, plus the concept of roadside hazard management. This is very important, particularly for the high risk roads, the crash barriers and clear zone concept, etc. Also, the process of risk assessment on such roads, UK and Australia, they have very good road safety audit guideline, a systematic process. Also, the safe system assessment framework widely used in Australia. So we have some good practice available internationally, and these needs to be adopted as a benchmark in addition to the national standards. So like Indonesia, where national standards are there, in addition to the national standards, we can look at such good practice available to make the road safer. I mean, make the road design safer and operation also. Now, star rating of the roads at design stage. particularly what Han is going to talk about in next module, star rating for design SR4D. The Asian Development Bank has put together a good manual for the correct region, that is the Central Asian region. Combination of star rating for design and road safety audit. So you know that when the designs are being prepared, typically road safety audit is conducted. It is the design goes through the process of road safety audit by an independent party. How can we complement this process with star rating of the road design? This is what this guide provides a guidance on. There are 3 levels of integration possible. Level 1 is very quick, where you have such cross sections from the design. We can do star rating of such cross sections. Level 2 is full length star rating. So the full length of the road based on the design drawings and documents, we can do star rating. That is what we have done actually for the TSTR link in under this study. And level 3 is star rating plus fatality estimation. So if we do existing road before improvement, full star rating, and then do design star rating, we can compare existing road versus design. And this process, in addition to the road safety audit is a very good process, and both of them are complementing each other, because road safety audit gives more detailed perspective, which sometimes the automatic system of star rating may miss. So road safety audit is also very good detailed approach. And again, under this study, we have done road safety audit as well. So that's a way how we can complement the process of road safety audit. Now I'm going to share quickly some good safety treatments or good practice solutions which we can consider not only for the TSTR link but generally on the road network. So pedestrian treatments, where you can see that pedestrians are at risk. Some of the treatments like footpath, providing footpath, clear footpath on both sides, raised crosswalk, so tabletop crossing where pedestrian can cross and vehicles will have to slow down. So it acts as a dual traffic calming plus pedestrian crossing facility. And signs and marking with such facility. So this table here shows effectiveness. For example, raised crosswalk, the cost of implementation or the construction cost is medium. Timeline, within 1 to 2 years, you can plan, design, and construct. That's the timeline. Effectiveness is about 40 to 60% in reducing pedestrian casualties. Treatment life is 20 years. So once constructed, with good maintenance, it can go on for 20 years. Traffic calming measures, vertical deflection, where vehicles will have to slow down and go through, for example, speed cushions, which allows bigger vehicles like ambulance and school buses to pass through without the hump. Speed tables, where all the vehicles will have to slow down and go through. And as I mentioned, pedestrians can also cross from that place. Speed humps, the traditional circular arch type speed hump. Then the traffic calming measure in terms of horizontal deflection, where the road narrowing effect, which gives driver and perception of road is narrowing, so drivers will slow down. So there are certain gateway treatments like this with different types of markings and signs. We can have a gateway effect, so the drivers know that they are entering into a village or urban area and they need to slow down. This is particularly when a highway is passing through a built-up town or village. We can also have central island like this to have that slowdown effect. This is a good example of gateway village from New Zealand, where you can see both sides the speed limit sign with name of town they are approaching, speed limit also marked here, and this type of effect. It tells driver that you are approaching a village or town and you need to slow down. Some more examples of gateway treatment, which are very effective when you have a high-speed highway passing through village. or town having this kind of signs on both sides, plus the central island having rumble strips like this on the road, or maybe different type of island, different shape of island, that is very effective. Runoff crashes, where you see more crashes are happening where vehicles go off the road, and this is very serious in case of hill roads, where crash barriers can be very helpful to reduce. Also with good signs and marking, we can improve that situation. Clear zone treatment, where based on the traffic volume and speed and class of the road, a minimum width of ranging from 3 meter to 10 meter is required, where no hard object is present. So when a vehicle goes off, it doesn't collide with such object, and that improves the situation. Again, shoulder rumble strips very effective. Curve widening, when you have a sharp curves, little bit of widening. Paved shoulders are very effective as well. Treatments which helps to reduce head-on crashes when undivided road is there and vehicles traveling opposite direction. So we can have different treatment in the center line rumble strips, climbing lanes on hill roads, so faster vehicles can use that extra lane to overtake slower vehicles. Good center line markings are also helpful. There are a variety of center line markings. To improve junction safety, channelizing is very important, and you can see here the markings and channelizing island on the intersection that helps to regulate the movement and reduce the conflict between turning vehicles. Signalization, very helpful. Blinkers to alert drivers in advance that you are approaching an intersection. Roundabouts are also very important, and they reduce the conflict by a great amount. So having roundabout on highways, in urban area definitely, but also on highways, it is very helpful. So these were some of the good practice solutions that I wanted to share with you. And in the next module, Han is going to talk more about how we have assessed the risk on the TSTR link design and given the solutions using the road safety audit and star rating for design approach. Thank you very much. Any questions? I'm happy to answer.
Okay, thank you, Mr. Jiges. For participant, maybe the question and answer will be after the second speaker. Now we continue with our second speaker, Ms. Han Hu, a senior engineer and deputy director at Beijing Zhongzhiuan Technology Co Limited. Her work focus on applying evidence-based approach to safe road infrastructure. This aligns strongly with today's session, where we will share the Jambi Rengat Toll Road design case study, including findings and improvement options. With great respect, Ms. Hanhu, are you ready?
Yep, thank you.
Okay, the floor is yours.
Okay, let me share my screen.
Okay, great.
So, okay. Okay. So on module 2, I'm going to talk about the project specific discussion on the design review and compliance and gaps and mitigation measures for the road safety review and enhancement for the Trans-Sumatra toll road from Jinto Kanan to Senjalan project. The scope of this link 15 is about 198 kilometers from Jambi to Rengat. And the objective is to review the detailed engineering design for road safety provisions and provide recommendations to enhance road safety aspects. What we have used, the methodology is what Jigesh just talked about, the International Road Assessment Program, the IRAP, star rating for design, SR4D, and also incorporate the road safety audit RSA methodology of the DED. to achieve Indonesia's MPWH Regulation Number 4, 2023, that mandates a minimum 4-star IRAP star rating, safety rating for all neutral roads and expressways. Let's take a look at the entire stretch of the road. There are 4 interchange from Cinto Kanan to Rengat, and there are 4 lanes and 2 lanes in each direction, and the total typical road width is 25.9 meter. That comprises of the lane width is 3.6 meter, and 1.5 meter inner shoulder width, and 3 meter of the outer shoulder width, with 2.6 meter median width, including the median barrier width. So what we have done is, first we implemented the road safety review of the DEDs. The workflow is we took the data of the TSTR link 15 DED and also the other reports, and have done the pre-audit checks, check the status of work and road functions, and then review from road safety aspects to review the road safety design features and identify the potential safety issues. And then we formed the road safety review report. And then we listing all the safety concerns with the level of risk and the priorities, and then recommendations to mitigate the risk. After that, we provided the review report to our clients, and then meeting with the project manager and designers, the PTHK, to discuss the safety concerns and recommendations for them to change, and to discuss how these measures will be implemented in their changes and design improves. So after that, we implement the SR4D work procedures, which I have introduced before. We circle this. This is a circle, and then we have the target that is the 4-star rating to optimize the star ratings of the entire road stretch to reduce the deaths and serious injuries that even it's the new roads, but it probably can cause some potential fatalities if we don't design it properly. And then we start rating for vehicles, occupants, motorcyclists. Normally we do for 4 vehicle occupants, but currently for groups of the road users. But for this project, we only do the star rating for the vehicle occupants. And then we implemented the economic assessment and investment plans, include the safety treatments in road design, and then update the road attribute coding, and then form this entire circle. We call it SR4D. So the SR4D road attributes coding include the roadside, mid-block, intersection, flow, and vulnerable road users, facilities, and land use, speeds, and extras, something extras. So for roadsides, for example, we code the roadside objects and their distance to a road lane, and then the paved shoulder width, paved shoulder rumble strips, are they available? And then for the mid blocks, here are the attributes we usually code the numbers of lanes and lane widths. Are there any service roads? And how about the curvature and quality of the curvature, and then the grades of the roads, the slope, and median type, center rumble, and then skid resistance is good, and the parking space, sight distance, and lighting. And for intersections, we call the intersection type, the quality of the intersection, and also channelization, intersecting road volume. And also for flow, we call the annual average daily traffic, and also the peak hour flow, pedestrian along and cross the flow, bicycle flow, and also the motorcycle volume of. And also for VRU, the vulnerable road users facilities, and also the land use, we call the sidewalk, pedestrian crossing, and provisions on the inspected and intersecting road, and the area type, and also the land use. the speeds we called the speed limit and also the operating speed, which often we use the 85th and the mean speed and the speed management. Are there any speed differences among each lens, and also the something extra like the image references and also comments and landmarks. So these are the 72 road attributes coding that we have done for each 100-meter of the roads section for each direction. And this is an example of the SR4D for the TSTR link 15, the typical cross-section, the road attributes coding for for the TSTR link 15 roads, that this TCS represents the barriers at both sides of the road, that you see at this stretch of the lens, that the red dots representing the existence of such TC, the typical cross sections. And what we code is in the roadside group, we code the roadside left object is the metal barrier, and the left side distance to this object is 5 to 10 meters. And we also code if there are any shoulder rumble strips. And for the right side distance to the object, we coded right side is because it's the median. We coded the concrete barrier, and also we code the right side distance to the object is 1 to 5 meters, and then the right side paved shoulder is 1 to 2.4 meters of this typical cross section on the roadside group. And for the mid block of this typical cross section, we call the number of lanes, and lane width is wide, and the curvature is straight, and curvature quality is not applicable from in this typical cross section. And also we call the median type is concrete, and the ski resistant, because the new roads we coded the sealed, which represents the good condition, and the parking we called none, and the grade we called it 0 to 7%, and road condition we called in good, and there's no roadworks obviously, and the side distance here is sufficient, and there's no service road, and the delineation is good, and center rumble strips does not apply, and lighting also apply here. For the intersection here, we says there's no intersection at this part, so all these attributes is not applicable. For the flow here, we because it's toll roads, we said there's no motorcycle and no pedestrians, and of course no pedestrian crossing flow, and pedestrian walking along the walking along the road, and also there's no bike flow. So yeah, we use this AADT as we got the basic concept design from the PTHK that they provided us. We use this 5,791 vehicles as the AADT. So the AADT represents the exposure of how many vehicles are exposed to this traffic. If it's a large number, that means more exposure and more risk that the vehicle occupants are facing on these road sections. So it often will influence the results of the star rating, the safer road investment plans, as will generate more fatalities. And for the VRU facilities and land use here, since the left-hand side land use is pure land, farmland, and we call there's no sidewalk and no crossing on this inspected road, and no crossing at the side road, and obvious no sidewalk on the right side, and So no motorcycle facilities on these toll roads, and the area type is farm, and there's no crossing facilities of vehicles, there's no crossing facilities quality, and there is no fence, and for bicycle facilities, and also school zone. So these are these all attributes. So typical more of time, if we code some school zone or some urban streets, and these attributes will be activated according to their actuals. And then we have a summary table of the TCS, particularly to these barriers at both sides, because most of the cases on this TSTR link 15, the both sides are barriers at both sides. So for the driver's side objects, it's concrete barrier and 1 to 5 meter distance. And for the passenger side objects, which is the left side, is the metal barrier, 5 to 10 meter distance to this object. And the paved shoulder width is wide. That is at passenger side is 2.5 meters, and driver side is 1 to 2.4 meters. And there's no shoulder rumble strips. And also for the mid block, the median type is divided road, and also the concrete barrier at the medians. And there are 2 lanes each carriageway, and the curvature is gently, and curvature or straight, and the delineation is adequate, and lighting is yes. For intersections here, there's no intersection, and the flow info is 5791 AADT, and land use is undeveloped, and the speed limit here is 100 kilometers per hour, and operating speed at this section is we used 85th percentile speed, that is 110 kilometers per hour, and the speed management here is nil, and speed differential here is nil. So for other typical intersections, cross sections are the side ditch at passenger side of the roads, where the passenger side objects is side ditches, and with the distance of 5 to 10 distance. And there are some open barrier place where we say the driver's side objects is unprotected barrier end. And there are places like the underpass bridge, where we found that passenger side objects is concrete barrier with 1 to 5 meter distance. And also for overpass, cross section is the passenger side objects side ditches with 1 to 5 meter distance. And for the rest area exit place, the delineation, there are places the delineation is poor. And for the rest area entry place, where the places, the delineation is poor, and the commercial access is more than 1 commercial access. And for the interchange exit, there are cross sections that we think the delineation is poor, and the merge lane section quality is also poor. So this is summary of the TCS, the typical cross sections of the entire TSTR link 15. And then we implement these input to the TSTR link 15 with the design review, and then using the IRAP's star rating for design method, inclusion of the safety treatment in the design. The output will be the revised and safer design and 3-star or better star rating. And then the safer new roads should be constructed. And the outcome should be the reduction in deaths and serious injuries. And impact should be the long-term economic benefits and less burden to the health system. So as Jigesh has introduced the UN's road safety goal, that the 12 goals involves the public health, and also the law enforcement, and also the road authorities. So we as the road authorities and as the designers, we have to do our obligations to make sure that our design will it make it possible to identify, will we able to identify the safety treatments or improvements under multiple options of the available investment plans. So that's we calculate the economic benefit of the safety treatment must at minimum exceed the cost of its construction and maintenance. That is, it must have a benefit and cost ratio, the BCR, greater than 1. If the threshold BCR will be lifted above 1.0 in this case, which will have the effect of reducing the overall cost of the plan. So, and also then we will found the major road safety findings that there are 3 major road safety findings after all. So the first one is the median opening barriers, and second is changes merge and diverge lane delineations, and the third is other road safety concerns. And our IRAP star rating for design results shows that 88.3% of the road sections will achieve 4-star, and there are several road sections that are still 2 or 3-star. And for the median openings that are in the previous TCS analysis, we said is the barrier open barriers place, that it's a U-turn provision for the emergency vehicles, which you can see in this graph, that in the current design is the collapsible barrier in the median, that there are about 31 such openings on the 198 kilometers road length of the TSTR link 15. And the collapsible barrier in the present design is a concern for road safety, as it will generate, in case of high-speed collision, it will generate the runoff crashes, and the vehicle may cross and go on the other side. And these collapsible barrier ends connect with the concrete barrier in the median are not safe for high-speed collision. And there are so many such U-turns that 31 on these 198 kilometers. An example of the star rating analysis of these median U-turn, median opening for emergency vehicles, the level of risk, you see the operating speed is 110 kilometers per hour, which we say is the 4-star. But the driver's side object, the unprotected barrier end here, make it 1-star or worse. And the median flexi post, we called it, make it 2-star risk. And the wide lane widths and wide outer shoulder widths give it outer space for more clearance, make it 5-star of these road sections. So the ultimate result of this cross section is 2-star. So for the interchange merge and diverge lane delineations for signings and markings and visibilities, we identified for the rest areas and interchange exits, the directional signs should be placed from 2 kilometer, 1 kilometer, and 500 meter. And the current designs are designed with the interval of 100 kilometer and 500 meter interval. And second issue is we should install some wet reflective markings and rumble strips to improve the lane discipline in rainy and nighttime conditions. And we should adopt a graded speed limit scheme, reducing the speed from 100 kilometers to 70 kilometers per hour, and then to 40 kilometers per hour. To safety transition drivers into the divergent lanes at the interchanges place. So, and the risk level of the interchange merge and diverge lane delineations for signs and markings, there's an example that, again, for the operating speed here, that is good. But for, we called it this divergent place as the intersection diverge lane and the pore channelization, and the delineation here we called it as pore delineation. And the good part of this is the roadside barriers at both sides of the road are designed, and there are wide lane widths and the wide shoulder widths. And this is the star rating maps of the TSTR lane 15 Jambi to Rengat to the vehicle occupants. And on the left side, you see that the smooth star rating 4-star is 99.2 percentage of the road length is 4-star. And then on the right side is, say, the raw star rating, which only 88.3% of the road length is 4-star. And there are the rest of the sections are 2 or 3 stars. So what we meant by the smooth star rating is we merge the homogeneous sections of the road, each 100-meter road sections, so that there are probably some sections are 3 stars, but the adjacent part, homogeneous sections, are 4-star or 5-star or better, and then the smooth stars will be 4-star. But for this raw stars rating, that means for each 100-meter section, the star rating. And our ultimate goal is to make all the raw star rating to be 4-star. So the safety concern here is opening for emergency vehicle access. And recommendation is we adopt more safer barrier type. And there are about 31 sites. And the second issue is the merge and diverge lanes of the interchanges to improve the signs and markings and also the crash barriers. And there are 8 sites. And also the space enforcement, and if there is any possibility to make sure the places are well placed with the speed cameras. And this will make the current DEDs, the star rating that you have seen, is there are about 10%, 12% of the roads are still 2 or 3 stars in terms of the raw star rating. And with our improved recommended treatments, we can eliminate the 2-star ratings here. But still, there are the road sections there are still about 10% of the road are in 3-star ratings. But if we can add up some speed enforcement, and then we make all the road sections to for the smooth star ratings to 100% 4-star ratings, and for raw star ratings we make it 99% of the road sections into 4-star ratings. That's almost 100% of the length achieves 4-star ratings or better star ratings. So for other safety recommendations, we identified is the VMS info and locations, where we identified there are some VMS showing the available parking slots is designed very near to the diversion area that we suggested to consider to relocate the signs, and specifically to relocate the sign ahead of the action point of the driver deceleration lane. And for speed cameras, for enforcement of the speed limit, need to confirm the locations. And the third is the animal fence. In the 2025 design changes comparisons, it is said that there are animal fences designed. It will be good to know if they are available for the entire length of the road sections, and also the entire lane 15 and the right-of-way fences are available. And for the vulnerable road users facilities, at the intersecting roads, intersection of the toll and non-toll roads, For example, the interchange of Jindo Kanan near the entry and exit from the TSTR interchange, the pedestrian crossing signs are designed, but the location of the crossings are not indicated. And we also suggested that the anti-glare screen in the median should be also installed to protect the traffic from the headlights on the oncoming traffic. This was adopted in the 2025 designs changes. And we also recommended for the work zone safety, we should shift to a safe system and risk-based approach, and to adopt the correct 6-zone work zone model that from early warning to advanced warning and taper and mandatory safety buffer, and then work area and then termination. And also the hierarchy of the controls, engineering first to eliminate risk where it is possible, to improve the crashworthy of the barriers and also the TMAs, and also to the administrative controls. And for the mandatory speed management, that 40 kilometers per hour in active work zone is mandated. And from a step down speed reduction, the 20 kilometers per hour increments of this step down speed reduction. And we also encouraged automated enforcement and regulatory speed signs. For the positive protection for workers, we recommend to adopt the MASH and also the EN 1317 compliant barriers, and also for the TMA, the track-mounted attenuators TMAs, mandatory on the high-speed sections, and the water-filled barriers for delineation only, they are not for protection. And for professionalized traffic control, to replace the flagman with the certified traffic controllers, and use the stop and slow buttons and portable signals and radar speed displays. And then we recommend to adopt the quality assurance and visibility, the daily 6C signage audit, the clear and comprehensive and credible and consistent and correct. And this will achieve the minimum visibility distance based on the operating speed. So this is basically we have identified, and this from the safety roads RSA and the RT, the safer roads SR4D, and the star rating for design, and also the star rating using the IRAP method, and also we benchmarking the good global work zone safety measures from CARAC and other countries, from Saudi Arabia and other countries' best practice on work zone safety. So also we, according to our work experiences with our PTHK, this year, they have already identified some of our suggestions. So we would like to floor to our clients and also the audience. If you have any questions, you can let us know. We're open for any discussions about these results. Thank you.
Okay, thank you, Ms. Han-Hu. Okay, thank you for the presentation. Maybe Ms. Han-Hu's mind is on the Chinese New Year, yeah, Ms. Han-Hu. But now we will have a discussion session. Is there anyone to raise your hand to have a question or statement? If not, maybe I will read the question from the chat. Maybe maybe Ms. Hanhu or Jikes can answer this one. First discussion is about the motorcyclists. Given that motorcyclists represent the largest proportion of road crash victims in Indonesia, and that toll road exclude motorcycle traffic, should national road safety strategies prioritize intervention on non-toll urban and arterial roads over toll roads upgrades? Do you have any comment, Pak Jikes, or?
Yes, I can answer this one. Good question, because when we say that 80% of the deaths happening with motorcycle, why don't we just focus on motorcycle? However, I would like to say that it should not be seen as a prioritization where we take action. I think the National Road Safety Policy also says that on toll roads, the crash rate is more than non-toll roads. What that means, if 100 crashes happen, how many people die? So number of deaths per 100 crash in a toll road or high-speed road will be much more than other roads, because other roads the speed is less. Maybe many crashes happen with injury and survival. But on the toll road, if a crash is happening, it's going to be high speed and may result in a death. So it should be taken as a parallel approach. Different type of measures are required on toll road, and different type of measures are required on non-toll roads where high speed only vehicles, etc. So my suggestion is to have both actions parallelly. Different actions on the non-toll roads for motorcycles, and toll roads for other vehicles, different type of actions. Yeah.
Okay. You want to add something, Ms. Hu?
Yes. So also we always, when we design a road, we first need to think about the functions or the objective of this road. Whether you want, as what Jikesh has said, whether you wanted to ensure the efficiency, the high speed, or you want to cater on all the let's say the traffic participants. So there must always be a calculation and also a compromise. First, to identify the functions. So this road, as what we understand, is the toll roads that to ensure the fast travel. And the high speed will occur more or severe crashes. And if the motorcyclists, they are traveling or with higher prioritized on these roads, and they need to be equipped with higher protections on themselves. So if like for our countries or some other countries, for instance, in Malaysia, they have their dedicated motorcycle lanes or routes that the drivers, they can motorcyclists, they can drive very safely with comparatively higher speed, but not to have this kind of mixed traffic, as we design these toll roads with 100 kilometers per hour travel speed, where often the vehicles can travel more than 120 kilometers per hour, which will cause very serious deaths or outcomes to the motorcyclists if the crash happens.
Okay, I think that's it's the different measure for the toll road and the non-toll road, because in toll road we don't have any motorcyclists, especially in Indonesia. Okay, do you have any ads, Pak Muhammad Fuadi? If no, we go to the second question from Insinyur Haris. I have visited several countries such as Malaysia and Singapore. Why is there a significant difference between Malaysia and Singapore compared to Indonesia in terms of road safety? Is it due to difference in approach or methodology? Could you explore, Mr. Jiges?
Yes, Singapore is a different story, because Singapore is smaller and much more disciplined in everything, not just roads, but everything is very much disciplined. So I'm sure the effect will be there on road safety as well. But one thing which makes clear, they have adopted safe system approach, and implementing the safe system approach that always shows the difference. Malaysia has also very good institutional capacity for highways and urban areas both. Indonesia, good thing, the policy is there. Now the next is to implement this policy by having all the safe system approach principle, having a good healthcare system, and enforcement of the speed on high speed roads is going to be very much important. So as far as I know, these are the reasons why we see difference in these countries.
Okay, because the scope, the Singapore is small cities, and maybe we in Indonesia, maybe the case is similar in with Malaysian.
Yeah, Singapore is very small and easy to be managed, and they have strong policies on the ownership of the vehicles and motorcyclists, and then it's different story. Yep.
Okay, we go to the third question from Mr. Mutakin. What is the design plan for the toll road on this section, considering that driver behavior on toll roads in Sumatra tends to differ from that in Java due to the relatively new toll roads on some sections compared to the older toll road in Java. For example, on certain toll roads, many trucks stop at the side of the toll road, and because of narrow shoulder design, the width of the vehicles can enter the toll road, causing accidents on the toll road. What about the plan for this toll road that relates to driver behavior? Yeah, maybe in Sumatra there are a truck driver parked on the shoulder of the toll road. Do you have any insight?
Yes. Yes, so on TSTR, the designs we have reviewed, there is wide paved shoulder on the outer side, 2.4 meter wide, which can easily, hold a truck. So truck width is about 2 meter, 2.2 meter to be max. So on that paved shoulder, a truck can easily park. But still there are chances that a truck parks not fully on the shoulder, but little bit on the lane, encroaching the lane. In such cases, and also where a truck is parked not in emergency, but for some other reason, need to have a good enforcement system, camera-based detection system, which can alert the center, control center, that a truck is halted or something like that, and then they dispatch a vehicle to help with the breakdown and remove the vehicle from such section. Maybe we can also think of some warning system like VMS, electronic display, which displays such incident so that drivers know in advance. I'm talking about solutions, but the shoulder is definitely wider in this case. I'm not sure what is the shoulder width in other case, what you have mentioned on the Java island, but here it is wider.
Okay, and then next question. Oh, please explain in more detail how the relationship between RS4D in IRAP and the road safety audit at the design stage. It is new for us, the starting for road safety audit. We already use Ashen who explained, we see before it's like Arab demonstrator, right? Arab demonstrator is similar with SR4D, but how about the road safety audit? It is new for us. Can you explore?
Yes, so I can explain in simple term. A road safety audit, when a road safety auditor reviews the design drawings and then gives some recommendation or some observation, there is no quantification of risk. So when I look at a design drawing and I say there is some risk in here, how much is the risk? That I cannot tell. When I say improvement changes, you need to change these features to improve safety. I cannot tell what is the level of safety improvement we are going to bring there. Road safety audit is very important because you can do much more detailed level with your own experience and observation. You can find out things, whereas star rating, it helps to get you level of safety. So when a road safety auditor identifies a risk, like what Han has said, we have median openings for emergency turning of vehicles, and then there are collapsible barriers to close such median opening. These collapsible barriers cannot hold a vehicle. When a vehicle goes off the road, it will collide and go on the other side. This collapsible barrier cannot stop a vehicle from going other side. So that is the detail level observation which comes from site visit or looking at the design drawings. When we do star rating of such, it tells, okay, in such type of crash barrier, it is 1 star. So which gives you level of safety. And when you change it to certain type, you get 4 star. So that is the way star rating complements the road safety audit process. Um, this is in very simple term, but then there are some more benefits and details. So I mean, conducting the both the road safety audit and star rating for design. Han, you want to add anything?
No, I'm fine.
Okay, the thing is, the IRAP has specific parameters, maybe 54 or something. But the
Right.
road safety audit is more like an art. It's more a subjective from the expert of road
Right.
safety. Is it enough? We are using the 54 parameters compared to the more subjective and more broader experience of the road safety auditor.
Yeah, in that sense, it is enough. It captures the way. However, you can always say there will be a limitation. We're doing star rating for design. That's why road safety audit helps to overcome that limitation. I can give you one example. If we look at intersection design, and then well, on this link there won't be any at grade intersection, but on general other road where you have a, let's say, 4-leg intersection, so vehicles are going to take turn to exit the intersection. So that lane for turning, if it is very large radius, vehicles can go through very high speed. So road safety audit, you can find out and tell that you need to reduce the radius slightly, so that vehicles will have to slow down and go out, or while entering on the highway they will have to slow down, and these kind of things. So that is the benefit of doing road safety audit, which, based on your observation or your experience, you can identify a hazard and then probably give a solution as well.
I want to add something.
Yes.
So what you guys said about the RSA, that tells you that the auditor can find out some problems of intersections, and then the auditors can also provide some solutions to this intersection improvement. But the SR4D or the IRAP the IRAP method is to complement this RSA. So they give the metrics, the IRAP methodology gave the metrics and quantifications of this level of improvements. Let's say we have improved intersections, and we don't know the metrics and the benefits. We don't know how much people and lives we can save by doing such engineering measures, and by investing some of the measures. Obviously, there will be some engineering cost, but the cost of the people, the lives, are also some benefits. So this will calculate the BCR, the benefit to cost ratio, that we use that to calculate these threshold, using that the 1.0 threshold to select the countermeasures that can be adopted to reduce the fatalities of the designs, the improvements. So these two measures should work together always. One helps you to have the basic and also some objective observations. The other one, the IRAP, the metrics, give you the quantifications. Okay, before any improvements, the star rating is 2-star. But after that, we have achieved 4-star, and also at the same time, we achieved saving maybe 200 and or whatever, how many people, the fatalities and serious injuries persons. And these are all can form a good business model to tell your engineering stories to your investors as well. Okay.
Okay. I think this topic is very interesting. Maybe we will discuss it later, Pak Jiges, Mr. Jiges, because we in Indonesia we already use the star rating, but it's the different approach with the road safety audit, because star rating, junior engineer can do star rating, but for the road safety audit it should be an expert with more long experience. Okay.
Right.
Next question. Does the design take into account adequate street lighting in accident-prone areas? About lighting, do you have any comment?
I think the entire sections are designed with the sufficient lighting according to our observations of the designs. So, and there are not so many, let's say, accident-prone areas.
Okay.
If it's proper design or the alignments are good. So, Jigesh, maybe can you also make some points?
Yes, streetlight, I think these are present. However, when we talk particularly about star rating model, streetlight gives benefit to the pedestrian safety. So if we think about two cars and their risk, streetlight versus no streetlight, in star rating, it is not there. It is same. But when you have pedestrian and then you see streetlight versus no streetlight, there will be difference in pedestrian safety rating. So streetlights are no doubt important, and perhaps you can say that's a limitation of star rating model. But in reality, streetlights are helpful. Also, sometimes on some of the high-speed roads, I have seen streetlights are introduced in some sections to break the monotony of driving. Particularly at night time, in some sections they have street light, not on the entire road, and so on. And if there is a known history of crashes on certain road sections at night time, probably having street light will help to address that situation.
Okay. Next, with the question, a short question from Pak Richard, but maybe the answer will be long. Can you briefly explain how road decoyometric design, such as curves, gradients, and side distance, affects user safety for this toll road?
Yes, a good question. Very basic technical part. So curvature and gradient, they affect more runoff crashes. So for example, if you have very sharp curvature, vehicle runoff chances are very high. Vehicle going off the road because of the curve at high speed are very high. When we have gradient, steep down gradient, vehicle going steep down gradient, there also vehicle runoff chances are more. So that is how it affects safety of runoff crashes. However, on curvature, when you have undivided road like 2-lane road, the head-on collision risk is also very high on curvatures. So that is how it affects the safety. I mean the overall safety. Side distance. I'm sure most of the highways are designed with the minimum stopping side distance or intermediate side distance criteria. So that is not generally the problem on highways. On the curvatures, sometimes when you have hill or some obstruction on inside, sight distance is obstructed, and that again increases the risk of head-on collision. Also, sight distance is important when you have pedestrian on the road. For example, if you have vehicles parked very near to the road edge and also pedestrian crossing the road, then sight distance of the pedestrian is obstructed, or vehicle driver cannot see pedestrian until the pedestrian exactly comes on the road. So that is how it affects safety. However, on this toll road, if we talk, curvatures are very gentle curvature, so there are no sharp curvature, there are no steep gradient, and side distance is not issue because pedestrians are not there, they are not crossing, and the design meets the stopping side distance criteria. So that's how the basic curvature gradient and side distance is not a major issue on this toll road design. However, another question which I have seen, they are mentioning about monotonous driving. If we have very long straight section, the crashes are more where vehicle, because of sleeping or some other distraction of driving, crashes happen, and that is real. We talk about curvature, but also the straight sections, they affect safety in a different, and this needs to be addressed in a different or more holistic way, having rest areas or change in the environment, like what I mentioned, introducing street light in some sections where there is no street light. In Europe, they use trees in a different way to change that monotony of driving. So there are multiple ways of addressing that issue. One of the engineering treatment is shoulder rumble strip, which we have recommended on this road section. So when a driver unknowingly goes off and tries to enter the shoulder rumble strip gives vibration. It is also known as audio tactile lane marking. That is one engineering solution to address this issue.
Okay, maybe you want to explain that so-called crash modification factors or risk factors. Maybe if uh, the curve is straight,
Yes,
the factors is
is one.
one,
Yes,
and if the curve is
very
yes,
sharp.
very
It is
sharp,
6. Yeah.
the factor is 0.4 for something
Yes,
like
yes.
that.
Yes, so based on the global crash research, if I can explain, if you look at the radius of curvature, when you have very sharp curvature, the crash rate is about 60. And when it is about straight, like radius of curvature is 1000 meter and so on, the crash rate is about 10. So the ratio between two is like 1:6. So when you have straight alignment, the crash or risk factor is 1, and very sharp curvature, risk factor is 6. So 6 times more chance of having a runoff risk on a very sharp curvature. That is based on the traditional kind of data. However, the other point, say we have 10-kilometer straight alignment on such expressway or motorway or toll road. In that case also we will see people going off the road, just because monotony in driving. So that's what I mentioned, some of the solutions.
Okay, we move to next question. The problem in Riau is problematic soil that cause long-term road damage. Driving behavior on the Sumatra Toll Road is filled with the habit of trucks parking on the shoulder of the road that are not equipped with reflector lights, so that accidents often occur. The presence of overloaded and overdimensioned traffic loads that cause road damage, the habit of drivers taking the fast lane at a slow speed is relevant to the statistical data on the causes of accidents. How does a person respond to a problematic soil and the relevance of descent to driver behavior on the Tol Sumatra Road? Because the soil is problematic, then the road pavement is a lot of potholes, then the trucks will not use the dedicated lane. So something like that. Do you have any comment, Pak Ciges? Miss Han?
Yes, I'm not an expert onto that pavement design, but at the time of design preparation, geological investigations of the soil must be done in a proper way to get enough CBR and design the pavement crust thickness. Also, I have seen in some countries overloading by the trucks. I'm not sure about that is a problem in Indonesia, but other countries, especially in Africa, it is so much that it damages the pavement very quickly. So like 5 years after opening a new road, the road is damaged because of overloading of the trucks. So we need to address these issues in a different manner, overloading of truck in a different style. The issue of the soil, which you have mentioned, I'm sure there is a solution in designing the pavement crust thickness and material in a better way to address that issue.
I also want to add some point. Although I'm not a pavement expert, but I have some working experiences on this topic. Is that have you ever tried to I don't know, like if they're using the ASHTO design method, or like which are your local like Indonesian pavement design method. Sometimes maybe the other countries design method may not apply to your case, even if the road is properly used by, there's no overloading cars, but given to the local conditions of the materials, the availability, and then probably some of the lab test using other combinations of the pavement design can be applied. We can discuss later, and then to see if maybe your materials using some other design methods can achieve better performance. That's for your reference. Some suggestions.
Okay. So the code should be tailored to Indonesian situation, right?
Yes, this is because recently I've helped because our institute worked with a lot of other countries in abroad topics on road pavement and designs as well. So we have a big lab here, as they recently help other countries to test their materials, because that country adopts the ASHTO methodologies, but the performance of the pavement does not achieve what they want to achieve. So we said maybe we can use you don't have to always listen to the CBR or ASHTO method. You can try to let them to give us their materials. So we imported their aggregates and their asphalt, and then we help them to use other design methods to improve their aggregates, like the compositions of the aggregates. By doing that, the performance of the road pavements are achieved. So I think this is a simple. I'm not expert on that, but I talked to the leaders what they have achieved. So they said by this you can see this whole the entire. It's a global situation. So maybe one method cannot fit for all cases. So each country had their own issues and their own situations to think of. Yeah, this is the suggestion from me.
Okay. Okay. Next question from Ihyadi. In fact, one of the causes of many accidents on toll road is due to inadequate supervision from managers or highway patrols. Yes, I think. What's your recommendation is basically about the road pavement or road inventory or road physical road. But actually the accident is accident factor is from the physical road, from the vehicle, and then the user. In your recommendation for the Jambi Rengat road, is there any recommendation related to this enforcement or speed control and something like that? Do you have
Yes.
any response?
Yes, we have recommended speed enforcement in the star rating for design. We have done a scenario. So I think Han can correct me. We have assumed or adopted 110 kilometer per hour as 85th percentile speed, and
Yep.
then so speed limit is 100 kilometer per hour, but without a
Yes.
good enforcement system, and because this road is going to be very nice, which encourages speeding, people will drive generally 10 kilometer per hour above the speed limit. So we have modeled that if people drive at 110, what is the safety outcome, star rating, etc. And then reducing it by 10 kilometer per hour so that you have camera system to have a good enforcement. What is the improved star rating? So this kind of analysis is possible using star rating model. So one of the recommendation is to have speed cameras. Now we can have a long discussion on what type of speed camera, etc. Because when you have speed camera, people slow down. After speed camera, they speed up again. We can have average sectional speed camera. So one camera at the starting and one camera at the end of say 2 kilometer or 3 kilometer section. So you monitor speed between in that 2 or 3 kilometer. But the other thing which is mentioned here, very important, highway patrol and supervision. Doing this manually is going to be very difficult. So running a patrol van continuously, that's going to be difficult. So my suggestion is to adopt electronic surveillance system with the help of camera or different type of sensors, having a control center which help you to identify situation where you need to intervene. I mean the highway patrol need to intervene to avoid accidents. So that's is my suggestion.
Do you wanna add, Han?
No, I'm fine.
Okay.
This one.
Okay, next question, maybe last, maybe. The segment in IRAP is defined per 100 meters, while hazard identification is based on the most dangerous hazard from the driver's side and passenger side. For example, if there is a 10-meter discontinuity in a metal safety barrier, is the treatment in IRAP calculated as 100 meters? Would the cost calculation become too high compared to the actual field condition? Is it necessary to manually recalculate the countermeasure? That's interesting question.
Yes, very interesting. And I can tell the person who has asked, they exactly know how the coding is done. So that's really good. I'm really pleased to see that. So yes, this is right. The example when you have 100-meter level coding and the crash barrier is there in 90-meter, but 10-meter it is missing or broken. So you tell in entire 100-meter crash barrier is not there. That's how we do. The highest risk object is considered. In the countermeasure, the software will identify you have to fix barrier in entire 100 meters. So cost will be actually more than the real cost of fixing the 10 meter. So that's the limitation that we have. It is possible to do that recalculation. So when you have investment plan, you take it and then you say in here 100-meter, we just need 10-meter crash barrier, not 100-meter. And you can change that countermeasure cost and redo the benefit analysis. So that is possible. So if that detail level analysis is required, it is possible. There is also a route review tool which is recently developed and available on the IRAP VIDA model, which helps you to review the recommended treatments and then select some of them which are feasible to implement, uh, and then rerun the model, redo the analysis with selected treatments. So that is also possible for such detail level analysis.
Okay. Yeah. Yes. I think that the IRAP is for or the star rating for the road is it's good enough, but to plan the investment, we still need, and the design, we still need the real engineer, yeah,
Yes,
the road engineer to calculate the measure, to draw the measure, to design the real measure. So it's only for the projection, for fast calculating, to
right.
pre-calculate the investment.
That's right.
Okay. Is there any question again for the audience?
Okay, can I ask for a minute, Mr. Radit?
Okay, Pak Wahyu.
Okay, to Mr. Jiges Besar, I want to know what the percentage of the maintenance costs are cheaper in Indonesia, Malaysia, and Singapore, and then how you can compare between three countries about that, and how to handle that. Thank you.
Okay,
Uh,
please.
Yeah, I'm not sure I have understood it fully, but the maintenance cost and construction cost is going to be different in different countries. So, if your question is particularly about IRAP star rating and investment plan, the construction cost, unit construction cost, there is a long list about 94 safety treatments, and we have detailed construction cost. So for each country, that has to be modified to suit with the local condition. Like Indonesia will have to have what is the construction cost of crash barrier in Indonesia. In Singapore, it is going to be different, and so on. That is one of the input we have to give to the model to prepare investment plan, and that is how the investment plan actually reflects local conditions. The cost, benefit, everything is reflecting these local conditions. I hope I have answered your question.
Okay, thank you very much. Okay, Mr. Radit, I think it's enough for me.
Okay, thank you, Pak Wahyu. Is there any more questions? Okay, it's interesting question. What is the role of rumble strips in improving safety? Rumble strip.
Yes, so there are two types of, or maybe different rumble strips. Shoulder rumble strip, when we talk, it is not across the entire road, it is just on the shoulder or just on the edge line. So when vehicle goes off the road because of some reason, vehicle leaves the lane and goes on the off the road, that rumble strip gives vibration. So when driver is unaware that his or her vehicle is going off, that gives vibratory and auditory warning to the driver that you are going off the road, and that gives chance to recover and come back. We also have another type of rumble strip which is across the road. So entire lane you have white or yellow bar markings, multiple, maybe 5 or 6 in one go, and that is generally used to tell driver that you are approaching a high risk location, maybe where pedestrians are there, or a curvature is there, and so on, to get the attention of the driver, uh, or to change monotony in driving. So that's
Okay.
how it helps to attract attention of the driver, and then driver may slow down or pay more attention to the situation.
Okay, thank you. We have one person raise hand. Okay, do you have any question, Pak Rizky Pratomo?
Okay, thank you, Mr. Adib. I'm interested in smooth star rating. If I'm not mistaken, if the main road meets the merging lane, it is included into into an intersection. Uh, Sometimes we find it's hard to make a better star rating for that intersection, especially in the toll road when the speed when the operational speed is 100 kilometer per hour. Is there any recommendation to make a better star rating at that segment? except lowering the operational speed. Thank you, Mr. Adi.
Okay, Pak Ciges, it's about the smoother and the intersection. I think.
Yeah, so I think you are saying when there is a merge lane type intersection where traffic is merging on the road, um, there you have 100 km/h speed limit, which is similar to this road TSTR link, where we have speed limit of 100 km/h, and then merge road intersections near the interchange from where the traffic can enter onto the toll road. Improving safety on such it's a bit challenging. The basic thing which we need to have is good channelization and acceleration lane, because you mentioned 100 km/h, it's very high speed. So you want to make sure that the vehicles which are merging, they have acceleration lane so they can accelerate, come to nearly similar speed of highway speed, and then merge. So that is a safer merging situation. um, so yes, if the speed limits are high, the infrastructure has to be, that way. So signs and marking to have proper delineation and channelizing island, the hatch marking, if you know, in the gore area or corner area, and then acceleration lane on such high speed roads.
Okay, that's it. That's it. Answer, Pak Rizky? Or do you have any addition, Miss?
No.
Okay, maybe I have the last question. Due to budget constraint, the toll road is being built in stages, stage by stage. Is it possible to build a toll road with one lane per direction? Is it safety enough? So it's only for the freeway. It's only one lane, but for one direction, using the inner shoulder and outer shoulder. How your response?
No, I don't think it's going to be safe, because one thing, when you have just one lane per direction, then is it going to be construction zone between the two lanes, or just
Not really. Not there are no construction zone because the investment, because the money, so it's only built one lane first, of course, with the inner shoulder and outer shoulders, and maybe the next step 5 years again we will the add the another lane.
no. So okay, I understand. So the current system is construct like 20 km complete, then go to the next phase, construct another 20 or 50 km, and so on, right? That's the current. But what you are suggesting is do the entire thing with just one lane.
Yep.
No, two reasons. Because when you have just two lanes, it is going to be undivided road, or maybe physical median. But what if a vehicle is stranded? The entire road is blocked. If a truck stops on that lane, the entire road is stopped. That is one. Another point, when you have construction in next phase of another lane construction starts, then it will be going to be very difficult to manage safety during the construction, because you have live traffic, that to high speed, and then you have construction going on. So you'll have to again reduce speed limit that time to like 30 or 40 or 50 km/h, and so on. So I think it is still good to have the what you have current system, do phase wise, do it in bunches like 10, 20 or 50 km complete, if possible, to open for the traffic if there is connectivity through other roads, and then go for the other phase.
Okay, do you add something, Han?
I totally agree with what Jigesh has recommended. Do it phase by phase, like limited lens is okay. Otherwise, not even for the traffic block, and also for the manage the live traffic. Also, you have to think about if you build entire lengths of the roads for one time, and then you attract a lot of other business along the roads and then when you're going to expand for the next to expand it to 2 lanes per direction, you are facing to reallocate these new people. In the end, you will find another route. You abandon this old route, and then you previously goal or the preliminary goal to make it toll roads will be useless. Think about this.
Okay.
Yeah, so face to face, make it a toll roads, even it's a short distance. I think we'll have the better benefit because, and then by the facing, and then you already get the land acquisition of such big lands along the roads. You got my point, right?
Okay.
Yeah.
Because the behind the thinking from the investor is if we operate from gate to gate, we will get the tariff from the traffic. So they will get the money first. But if we not section by section, the toll road will not operate and the money will not come earlier. Okay. Okay, I think the time is up. Maybe I will summary a little bit. First, allow me to summarize the key message. First, toll road safety must be a core design and performance requirement. Must be a requirement. Second, tools such as IRAP SR4D is important to risk identification and prioritization. And then lastly, the true impact is by turning recommendation into actions. Otherwise, it only will become a ton of paperwork in the cupboard. So the recommendation should be become an action. Okay, thank you again to our speakers and our participants. To close this webinar, we are honored to invite closing remarks from the executive director of the PI. Is there any? Pak Arinova, time is yours, Pak Ari.
Yeah, thank you, Pak Adip. Can you hear me, Pak Adip?
Yes.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, our distinguished speakers, fellow engineers, and all participants. On behalf of our chairman of PK Sipil, Pak Habibie Razak, I would like to extend his sincere apologies for being unable to join us today due to last-minute schedule conflict, but he's been following the highlights and is very pleased with how the discussion went and has asked me to deliver the closing remarks. Today discussion on the Trans-Sumatera Toll Road, ya, Pak Adip, ya, specifically on the section of Jambi Rengat is a paramount of importance as we move toward to more connected Indonesia. The safety to our infrastructure must be our highest priority. Thank you for the conclusion, Pak Adip. And we would like to express our deepest gratitude to our esteemed speakers, Ms. Hanhu and Mr. Jikesh Bafsar. I want to give a special shout out and big thank you to our head of the transport subsector, Pak Dedi Gunawan. And for this is second or third collaboration with AIB, ya, Pak Adip, ya, for this mission. And we truly appreciate the hard work in bringing this continuous partnership to elevate our national engineering standards. We also wish to thank our moderator too, Dr. Adip, for excellently facilitating such an insightful and productive dialogue. To all engineers and participants here, I checked more than 220 participants this afternoon. Let us continue to uphold the highest standards of professional integrity and safety in our civil engineering practices. With that, I officially declare this webinar closed. Thanks for being part of this webinar. Stay safe, and see you for the next webinar. Thank you all. Thank you.
Thank you, Pak Ari. Ladies and gentlemen,
Pak Adip and all.
This concludes the International Webinar of Road Safety.
Thank you.
Thank you.
Thank you all.
Good afternoon.
Bye.
Good afternoon.
Happy Chinese New Year, Miss Han Hu.
Thank you. 恭喜发财.
Yeah.
Gong
Because
xi fa cai.
And
happy
Get well.
happy
Get
holiday,
well
Pak
the
Adib.
next year.
Yes.
Okay, yeah, thank
Happy
you.
holiday.
Fa cai.
Ramadan
Thank you.
Kareem, Ramadan Kareem.
Ramadan also.
Ramadan
Ramadan
Kareem
also,
also.
yeah.
Ramadan Kareem.
Thank you, Mister.
Bye
Thank you.
bye.
Thank
Much.
you.
Bye-bye.
Bye.
Yeah, goodbye. See you again.
Insinyur Indonesia senantiasa menjunjung tinggi integritasnya, bekerja sungguh-sungguh dengan semangat, profesionalismenya, utamakan keluhuran budi, amalkan ilmu dengan kompetensi, berikan yang terbaik, selalu yang terbaik sebagai karya baktimu. Teruslah berjuang membangun Indonesia, sejahterakanlah bangsa dan negara. PII Persatuan Insinyur Indonesia. Insinyur Indonesia senantiasa menjunjung tinggi integritasnya, bekerja sungguh-sungguh dengan semangat, profesionalismenya, utamakan keluhuran budi, amalkan ilmu dengan kompetensi, berikan yang terbaik, selalu yang terbaik sebagai karya baktimu.